ओके सो हेलो स्टूडेंट्स, वेलकम टू ऑल ऑफ यू. दिस इज सुयश बाजपेयी, सुयश भैया है इन फ्रंट ऑफ यू. ठीक है, तो बेटा अभी तक हम लोग ने काफ़ी सारे कॉन्सेप्ट देख लिए. टिल नाउ वी हैव सीन लॉट्स ऑफ कॉन्सेप्ट्स बेस्ड ऑन पोजीशन. ओके, and we have seen the concept of displacement and distance. We have seen what is velocity, average velocity, what is average speed, what is average acceleration. Then we have moved on towards a numerical, and then we have solved some more numerical based on the concept of average speed, average velocity, and average acceleration. And then we have talked about the instantaneous velocity or instantaneous acceleration, which is nothing but the velocity at a particular instant, right? Instant of a journey, right? And acceleration instantaneous acceleration is the acceleration at a particular instant. Suppose that t equals to 1, t equals to 2. So these instantaneous values can be find from the graph information or from the equation information. Suppose x as a function of time is given, right? So we can differentiate this to find velocity as a function of time. Clear? This will give you velocity as a function of time, and if you will differentiate this velocity dv by dt, then you will get acceleration as a function of time, right? So that's how we will move here in this case. Okay, we have seen some example based on that, right? We have solved 2 to 3 examples, and today we will see one basic example based on our simple concept, and then we will move to the concept of, and then we'll move towards the concept of the concepts of uniformly accelerated motion. I have already told you that this section have been this chapter of 1D motion, kinematics 1D. Okay, this motion have been divided into four verticals. That is, first is position, in which we have talked about position, distance, displacement, distance, speed, velocity, acceleration, average and instantaneous values of that. And in the next section we'll talk about uniformly accelerated motion. So today we'll move on this section. All right, then we will discuss some problems based on uniformly accelerated motion, then we'll discuss graphical problems, and then this chapter will end, and then we'll move to 2D motion. All right students, I hope this thing is very much clear to you. Chalo. So without any further ado, let's move towards a good example today, and let's solve this. Then we'll move towards our next topic, that is uniformly accelerated motion. All right, chalo bhai. Okay students, चलो तो शुरू करते हैं बिना किसी टाइम वेस्टिंग के. ठीक है, सो हियर वी हैव आवर न्यूमेरिकल बेस्ड ऑन दिस concept of simple the concept of average velocity and average speed, you can say. Yeah, so a table clock has its minute hand 4 centimeter long. Clear? So minute hand, this will be the hour. Okay, so suppose this is your table clock. Okay everyone, so and this is your minute hand, suppose this, right? So this hour is given to as 4 centimeter. All right, so now yeah, find the average velocity of the tip of the minute hand. A velocity, you have to find the velocity, right, of the tip of the minute hand between a part. Let's solve the a part first. Between 6 a.m. to 6:30 a.m. So where is the minute hand? Where is the minute hand? The clock has 3 hands, right? So one is hour hand, one is minute hand, and the other one is second hand, right? 3 hands the clock has. So now we are talking about this minute hand. Okay, minute hand, this minute hand complete its full rotation in 60 minutes. All right, so it has been asked what is the velocity of this tip of the minute hand when between 6 a.m. to 6:30 a.m. So at 6 a.m. this minute hand is somewhere here. Okay, at 6:30 a.m. the minute hand is somewhere here. All right student, so let us focus on the tip. So the tip have been moved from here to here, right? So what is the velocity? So you know that, right? Velocity is simply displacement upon time. Okay, you can say the displacement upon time, or you can say simply delta x upon delta t. That's it, right? Just think. So what is the displacement? The shortest distance between initial and final position. So this is your initial position here, and this is your final position here. Just check, right? This is your final position. So what is the shortest distance? This diameter. All right, just check all of you. So the displacement is simply 2 times r divided by what is the time taken. Time taken, you know, when the clock between 6 a.m. to 6:30 a.m. What is the time taken? 30 minutes. All right, just check. So divided by 30 minutes. So this is your answer. If your r is 4, so it will be 8 upon 30 centimeter per minute. This is your velocity. Just think, all of you. I hope this thing is very much clear to all of you. Okay, so yeah, let me write it for you from permanent marker. Okay, so velocity is equals to displacement upon time. Okay, taken. So what is displacement? That is 2r, because the clock have been, this is your minute hand, and it reaches from here to here, right? From in the a part, from 6 a.m. to 6:30 a.m. Okay, the motion of the minute hand will be like this. So the displacement of the tip is 2r divided by the time taken is 30 minutes. So it is simply 8 by 30. You can solve. This is the unit is centimeter per minute. All right, just check, all of you. Now the b part. Let us solve the b part now. Okay, so between 6 a.m. to 6:30 p.m. Now this time again the velocity, right? So where will be the minute hand? Where will be the minute hand at 6 a.m.? So it will be in this direction, right? So at 6:30 p.m. so from a.m., right? 6 a.m. to 7 a.m. to 8 a.m., 9 a.m., 10 a.m., 11 a.m., right? Again 12 a.m. and 1 a.m., 2 a.m., 3 a.m., 4 a.m., 5 a.m., 6 a.m. This will be here, right? Just check, all of you. So at from 6 a.m. to 6 p.m. this minute hand will move from here to here simply, right? This is the initial position of the tip, and this is the final position of the tip. The displacement will remain the same, 2r. Just check, all of you. Displacement is 2r, but the time is not 30 minutes this time, right? So what is the time? It is 12 hour plus 30 minutes. Okay, so 12 hour means 6 a.m. to 6 p.m. it is 12 hour. So 12 into 60, right? And plus 30 minutes. That's it. Just check, everyone. So it is again 8 divided by, it is what, 72750. Okay, yes, centimeter per minute. All of you just check. This is the velocity this time now, part B. Clear? So let me solve this for you by a permanent marker. So it is like this, right? So this will cover some rotations. This tip will cover some rotation, and at 6:30 p.m. this will be the minute hand, and at 6 a.m. this will be the minute hand, right? So the displacement is again 2r, but the time taken is 12 hours plus 30 minutes. So 12 hours into 60, this minute plus 30 minutes. So it is like this, 2r divided by 750. So it will be 8 by 750. Yes, simple. Centimeter per minute. Clear? Just check, everyone. I hope this thing is very much clear to you. Okay, if you have any problem, you can pause the video. You can see the solution once again. Just try it by yourself, and then you will learn a lot of things from this question. Okay, so now students, we will move to our next topic, that is uniformly accelerated motion. Okay, now we'll move towards uniformly accelerated motion. All right. Uniformly accelerated motion. Okay, भैया मेरी राइटिंग थोड़ी सी ख़राब है, just pardon me for this, right? Yeah, uniformly accelerated motion. So what do you mean by uniformly accelerated motion? So let me tell you first about uniform motion. Okay, uniform motion, these are the two different things. Okay, when you will say uniform motion, then note down the point that velocity is equals to constant. Okay, in this case velocity is equals to constant in uniform motion, and acceleration is equals to 0. But in case of uniformly accelerated motion, your acceleration is equals to constant. Okay, it may be positive or negative, right? So there is slight difference between uniformly accelerated motion and uniform motion. I hope this thing is very much clear to you. So that's written here also. So if acceleration is 0, or you can say force is 0 on a particle, on an object, then the acceleration is 0 clear in a straight line motion, and the motion is known as uniform motion because the velocity does not change One can also say that the particle is moving with a constant velocity. The average velocity in an interval and the instantaneous velocity are equal in this motion. Average velocity, V average, and instantaneous will always be equal in this case, right? Because there is no acceleration. Velocity is constant, right? And what do you mean by uniformly accelerated motion? So if force is constant or acceleration is constant, then the motion is said to be uniformly accelerated motion. What is the example of this uniformly accelerated motion? Yeah, freely falling body. Okay, suppose you have a ball here, right? A ball, and you drop this ball. Clear? What will happen? This is your earth. This ball will come down, right? So in this case, the force on this ball is only the acceleration due to gravity. The force is acceleration, the force is gravity force, right? The force is equal to gravity force, you can say. Clear? Okay, and acceleration here is only g, downwards, g in the downward direction, right? So this g is constant. The value of this g is equals to 9.8 meter per second square, and in some numericals we will take it to be as 10 meter per second square. All right, no problem in that. I hope this thing is very much clear. All right, students, so this is the example of this freely falling body. Okay, freely falling body or motion in gravity is always a uniformly accelerated motion. Okay, example of uniformly accelerated motion. All right, is this thing clear to you, all of you? Just write down in comments, everyone. Okay, so this is the example of free falling body. So we'll deal with free falling body we will deal with some numericals based on that. Okay, so before that, let me tell you some things, some important things. Okay, yeah, if acceleration or force is in same direction as velocity, then speed of the particle will increase. Suppose if acceleration due to gravity, let us take this example. Okay, so suppose body is coming downward and acceleration is also downward, right? Means velocity is downward and acceleration is downward, then the velocity will increase as happening in this case. But suppose, let us take one more case. We'll throw this body in the upward direction, right? Let us the velocity to be 5 meter per second. What will happen? The velocity will decrease. As this ball will go up, the velocity will decrease, right? Why? Because the acceleration due to gravity is in downward direction. So A is in downward direction. So if acceleration and force is in opposite direction to the velocity, then the speed decreases. The particles slow down. This situation is known as retardation. All right, students. So this is the example of retardation. This is example of acceleration, right? In this case, acceleration is negative, right? So we'll deal with a lot of things, but before moving towards the uniformly accelerated motion, let me tell you 3 questions. All right, let me tell you 3 questions first. All right, I hope you all have noted down everything. Clear? So let me tell you the equations of uniformly accelerated motion. Okay, all right, everyone. Yeah, the equations of uniformly accelerated motion, very important thing. Okay, students, so we have 3 equations. In when the acceleration is uniform, we can use 3 equations. One equation is v is equals to u plus at. The second equation is s equals to ut plus half at square. You all have read this in 9th class also. V square is equals to u square plus 2as. Just check everyone, right? Where s for where suppose a particle have been started at initial velocity u. Clear? U, and after some time the speed, the velocity will become v. This is your final velocity, this is your initial velocity. Clear? And the acceleration in this journey is small a, and the time taken is t, right? So let me derive these equations for you. All right, so yeah, so students, yeah, let me know everything here. What is acceleration? Acceleration is equals to final velocity minus initial velocity divided by time. Clear? So from here you will get this equation first. Check. V equals to, yeah, u plus at, right? Just check everyone. Then let us solve for second equation. Okay, for second equation, what we'll do, speed is equals to, sorry, displacement. Okay, what we'll do is displacement is equals to velocity into time, but velocity will be average velocity. So v plus u by 2, this is average velocity, into time. Okay, we'll put the value from first equation here, and what we'll get, this will be u plus at plus u into t divided by 2. Just check everyone. Okay, so when you will solve this, and here you will have s, when you will solve this, you will get reach to second equation, right? Okay, now let me derive the third equation for you. So for deriving third equation, just square, just do the square. 1 minute. Yeah, so actually the battery of the pencil have been finished, right? So just wait for a while everyone. Okay, now I think it will work. Yes. Okay, so for third equation, okay, you have first equation, u is v is equals to u plus at, right? Square both side, you will have v square is equals to u plus at square. So u square plus a square t square plus 2u a plus b ka whole square, right? Clear? Now you will have u square plus, take 2a to be as common. Okay, and here you will have what, just check everyone, 2a you have taken as common, so here you will have half a t square. Just check, 2a you have taken common from here. Okay, from here you have taken 2a common, means divide by 2a, right? Plus ut plus half a t square. What is this? From second equation, it is s, right? So it will become u square plus 2a, s for displacement, and here we have v square. Just check. So this is the kind of derivation of these three equations, right? And yeah, so what is displacement? This is the displacement. Okay, this is the displacement. So if you'll check these three equations, okay, these are known as equation of uniformly accelerated motion. Clear? So equation 1, 2 and 3. All right, so in these three equations, each quantity is a vector quantity except time. Clear? Just check all of you, right? So we have to define a sign convention here also, right? So I am defining a sign convention, and you have to follow this everywhere. So this is your y-axis, this is your x-axis, right? So whatever the quantity will be in the direction of positive x-axis will be positive, in the negative x-axis will be negative, in the positive y-axis will be positive. Clear? Positive, sorry. Okay, in the negative y-axis will be negative. That's it, simple sign convention, right? We'll use this sign convention everywhere. If you have defined any other sign convention, you can use that. So let me write these three equations for gravity kind of a case. Okay, so we have dropped a ball. Clear? We have dropped a ball from a height h. Clear? And we are writing these three equations for this kind of a case. Clear? This is a case, and I have to write let's suppose this is a case first. Okay, example, this is example, and I have to write, means when we are dropping anything, then u is equals to 0, right? So let us write these three equations for this. Okay, so v is equals to u0, right? So 0 minus gt. Why minus gt? Because the direction of acceleration in this case is downward, and downward is negative. Just check all of you, right? So acceleration here is equals to a is equals to minus g, right? So this is your first equation. Check. Second equation, displacement, right? S equals to, ut, u is 0 minus half gt square. Okay, just check all of you. Now the third equation, v square is equals to 0 minus 2g and s. Clear? Just check all of you. Okay, this is second equation, this is third equation. All of you think. Okay, is that clear to you? Now suppose the students, you have to find the final velocity, okay, when this ball will hit the ground, right? So this is your first initial position, this will be your initial position, this will be your final position. You have to find the final velocity. Clear? So you can use this equation if you know the time, right? Clear? And when you will solve this, you will get negative, answer negative, right? So why this negative sign? What this negative sign will tell you, that final velocity will be in the downward direction. If you will solve this equation, you will get your displacement, which will be negative again. So what this negative sign tell you? that the displacement will be in the downward direction. What is displacement? The distance between initial and final position. What is the direction of displacement? From initial position to final position, arrow this, right? This is displacement direction. So everything you can get from this sign convention. Okay, you will solve the quantities. आप उन quantities को solve करोगे जो आपको नहीं पता है, ठीक है? पहले तो जो भी given है वो हम लिख लेंगे, ठीक है? Whatever given we will write. Clear? Whatever given we will write. और जो भी निकालना है वो हम निकालेंगे, यूज़ करेंगे साइन कन्वेंशन, जैसा कि मैंने बताया, ठीक है? एट लास्ट जो भी चीज़ें हमें मिलेंगी वो साइन कन्वेंशन के साथ मिलेंगी, तो फिर हम समझ जाएंगे अगर नेगेटिव है तो उसका क्या मतलब है ना? So that's how we'll move in this question, in these sort of cases. So now let us solve one example based on this. Clear? Let us solve one example based on this concept. Okay, I hope this thing is very much clear to all of you. Okay, everyone. So this is your first example we need to solve here, right? Let us solve this. Okay. First of all, you have to take the screenshot. You have to take the screenshot and you have to pause the screen and you have to solve this question completely first. Clear? Then you have to see the solution. Clear? I hope आप सभी ने पॉज करके सॉल्व कर लिया होगा इस क्वेश्चन को. चलो अब हम सॉल्व करते हैं भाई, ठीक है? सो अ बॉल थ्रोन अप फ्रॉम द ग्राउंड रीचेज अ मैक्सिमम हाइट ऑफ 20 मीटर. क्लियर? तो भैया ये ग्राउंड है मान लेते हैं. क्लियर? अ बॉल इज थ्रोन अप, राइट? क्लियर? लेट मी मेक इट फ्रॉम अ परमानेंट काइंड ऑफ थिंग. Okay, just wait. All right. Yeah. So students, this is your ground, suppose. Clear? And a ball is thrown up. Clear? A ball is thrown up like this. Okay, clear? And it has reached to the maximum height somewhere here. Clear? When a ball is thrown with some velocity v, it will go up, and at a point its velocity will become 0. That will be the maximum height of the ball achieved, right? Then this ball will start coming down. Clear? So this is the thing we all know, right? We all know these things. Okay, everyone. So again the battery have been finished or the pencil. Just give me 1 minute and just think about this question. So this ball is going upward. Clear? And at maximum height its velocity will 0. So the maximum height is given in the question. All right, now let me try. Okay, so yes, so the maximum height is given, that the ball have been reached to the maximum height, what, to the maximum height of 20 meter. H max is given. Okay, so what is, you have to find the initial velocity, you have to find. Okay, so let the initial velocity to be u. Okay, so what will be the final velocity? This is your initial position. Okay, this is your initial position, this is your final position. Okay, so this is your initial velocity u. Let us suppose this is what we have to find. Okay, so let the final velocity to be v. All right, so the displacement have been given to you. Which equation will you use? Also, so v is equals to 0, right? U we have to find. Acceleration we know, what is that? Minus g, not g, right? Because it is in downward direction. Acceleration is always towards earth, right? Downwards. Acceleration due to gravity is towards earth, right? That is the only acceleration here. So a is equals to minus g, and we know the displacement. What is that? So displacement is equals to plus 20. Check all of you. Which equation will you use? Yeah, third equation, right? So third equation means first equation v equals to u plus at, second equation s equals to ut plus half at square, and third equation is equals to v square is equals to u square plus 2as. Think. Clear? So from here you will have v square to be as 0, u square you have to find, plus 2, what is a is minus g. Clear? And s is 20. Think. Plus 20, right? So from here you will have what? You will here you will have, when you solve this, you will have u square. Here you will have 20 into 2, 40 into, let's g to be 10, right? The value of g is 10, so it is 400. Okay, so 400 is equals to u square. So from here you will have this u to be equals to 20 meter per second. Is that clear to all of you? Just think, everyone, right? Very basic. Correct. So we solved it, right? So we use v square is equals to u square plus 2as. Clear? v0 u square is what we have to find, plus 2 in place of a minus g, in place of s plus 20. So from here you will have u is equals to plus 20 meter per second. What do you mean by plus? In the upward direction. That's it, right? Clear? Now the second part. Okay, now the second part, the time taken to reach the highest point. Okay, so now which equation will we use? You know that initially you don't know, clear. Now v you know 0, clear. A is equals to minus g and displacement is equals to plus 20. So from first equation we have solved, we know u also, that is 20, right? That is 20 from this solution, clear. Now we have to find what the time taken. So which equation can we use? Yeah, u we know. Now we also know, clear. U we know, v we know. Now we can use the first equation, yes, v is equals to u plus at. All right, so v is 0. What is u? U is 20, clear. And minus 10 t. So from here you will have t is equals to 2 seconds. Good, very good, right? You all have done that, I think. Good. Now its velocity just before hitting the ground. So when this ball will go up, and it reach to the maximum height, then after that what will happen? It will start coming down, and it will hit the ground again. So from the conservation of energy we can also say that the velocity at the time when the ball will hit is again the initial velocity, clear. Means it will be same as 20 meter per second. Or what you can do is you can again solve it, clear. Now when the ball is coming down, this will be your initial position, this will be your final position, clear. Now for this yellow color case, when the ball is coming down, okay, for this case, what is the initial velocity? Initial velocity u is equals to 0. And what is the final velocity? We don't know, clear. But acceleration we know, acceleration is equals to minus g again, displacement is equals to, now this time, minus 20, right? Check. And you can again solve it. You can solve for final velocity, right? Which equation will you use? Yeah, third equation. So for this case, c part, right? So v square is equals to u square plus 2as, okay, with sign convention. All right, with sign convention. Now this time our initial position is this, clear. Final position is this for this case, right? Clear. So v square, what is v square? V square we don't know, clear. So which equation can we use? What we have to find? The velocity. Yeah, we have to find, right? V square is equals to u square. What is u square? U is 0 plus 2, what is a? Minus 10, right? Again the battery has been finished, just 1 minute, students. Yeah, what is a? A is minus g. What is displacement? So in this case, this time the displacement is minus 20. Okay, just check. Yeah, so this is minus 10 g, right? A is minus 10. And what is the displacement? It is minus 20, everyone. Just check. Why minus 20? Because this time from here to here the displacement is in downward direction, clear. From initial position to final position. So it has been its velocity just before hitting the ground, okay. So we have taken this to be as initial point and this to be as final point, clear. So you will solve this and you will get this velocity to be as 20 meter per second. What one can do, you can take this to be as your initial position, right? And this to be as your final position also. Okay, one of you can think that I will take this to be as initial position and ball will go like this, come like this, and this will be our final position. So you can solve it for this also, right? Now this time your displacement is 0. If you will take this to be as initial position, this to be as final position, it depends on us, right? Clear. Means what we will take to be as initial, what we will take to be as final. Okay, in this time if you will use this equation again, this displacement is 0 and you will get this v is equals to u again, right? Means the velocity is in just reversed, right? But the magnitude is same, right? So we are getting this from here also, clear. So I hope this thing is very much clear to all of you. Now the fourth part, it's a displacement between 0.5 second and 2.5 second. So yeah, you know s equals to ut plus half at square, right? Clear. You can put the value of time, you can find s1, you can put the value of time again, you can find s2, you can subtract these two, and you can find the displacement between the time s equals to, yeah, between the time t equals to 0.5 second and 2.5 second. Just do it, you can do it, right? Clear. And tell the answer. You will have the solution in the next slide also. The time at which it is 15 meter above the ground. Yeah, we can also do it, right? Which equation can we use? You have to find the time at which it is 15 meter above the ground. So s equals to ut plus half at square. Just think, everyone, right? This equation can we use? So displacement is plus 15, clear. U, initial velocity, you know, that is 20. Time you have to find, clear. And it is plus half, what is a is minus g minus 10 and t square, right? This is quadratic question. You can solve this. You will have two values of time. Okay, it is quadratic question. You have two values of time, right? You will have two solution. You can use Sridharacharya or you can use middle term split method. Okay, middle term split. You will have two solutions. Okay, t1 and t2. Can anyone tell what does it means? Two solutions. Check. Check. What do you mean by this? This is E part, right? Clear? What do you mean by this? So means the body, this means you will have two solutions, means this ball will reach to this height, of 15 centimeter from the ground at two times. One time when it is going upward and one time when it is going downward. Clear? Two times it will meet. So one time is t1 and one time is t2. That's it. Okay, I hope this thing is very much clear to all of you. Okay, so this is the solution of this question what we have done. Clear? If you have any problem here in this case, in this question, right, or in these concepts, then you can directly reach out to me to our Telegram channel. All right, and here we are. So the link of the Telegram channel will be given in the description, right? So this is the solution of part A. Clear? Let me tell you this. This is the solution of part A. Clear? This is the solution of part A, and the solution of part B. The time taken to read, yeah, the solution of part B is this. Clear? The solution of part C is this. The solution of part D, you have to do it by yourself. I have given you the hint, and the solution of part E is this. I hope this thing is very much clear. Okay, so now let us move. Okay, students, let us move towards the next lecture. Thank you, students. That's all. Stay calm, stay motivated, stay blessed, stay focused, and yeah, best of luck. Let's crack it together. This is Suyej Bajpai, Suyej Bhaiya here in front of you. Thank you.